The while statement. Repetition statements allow us to execute statements multiple times. Often they are referred to as loops. Like conditional statements, they are controlled by Boolean expressions. Java has three kinds of repetition statements: the while, the do, and the for. The do and the for loops are discussed in Chapter 6. The while statement. A while statement has the following syntax. You have the reserved word while, and then you have parentheses, then you have the condition that's controlling the loop, then you have the statement that you want to execute. If the condition is true, the statement is executed. Then the condition is evaluated again. If it is still true, then the statement is executed again. The statement is executed repeatedly until the condition becomes false. Here is a flowchart. So in the flow of control, when you come to your while statement, you can evaluate the condition. If the condition is true, then you execute the statement, reevaluate the condition, and you can keep doing this loop over and over and over again. You can also come and evaluate the condition and the condition is false, and they can completely bypass the statement. So there's a chance that you might not even execute the statement if the condition is false at the very beginning. An example of a while statement. Int count. While count is less than 5. System out print line count. So what they're doing here is they're using a while loop to execute a statement a specific number of times. It is actually better to use a for loop to do something like this. The for loop is set up to handle the situation a little better. If the condition of the while loop is false initially, the statement is never executed. Therefore, the body of the loop will execute 0 or more times. Sentinel values. Let's look at some examples of loop processing. A loop can be used to maintain a running sum. A sentinel value is a special input value that represents the end of input. See average.java. So here's average.java. They have a driver class. They have three variables: sum, value, and count, and then they have the average. They create a scanner object. They ask the user to input some data, and they store that data into value. And while the value is not 0, they're adding the value to the sum, and then they're prompting the user again to enter in some more data. And then they're going to keep repeating this until the user enters in a 0. The 0 is what's going to stop this loop. That's what we call the sentinel value. So once they enter in a 0, this loop is going to stop, and then they're going to print out their running sum. Here's an example output. They ask for some numbers. They keep asking until you enter in a 0. Once you enter in a 0, that's when they calculate the average. Input validation. A loop can also be used for input validation, making a program more robust. It is generally a good idea to verify the input is valid, in whatever sense, when possible. See winning percentage.java. So here's their driver class. They have a constant for the number of games. They have an integer for 1. They have a ratio, and that's a double. They create a scanner object. They're prompting the user for the number of games 1. They're storing that value inside of the variable 1. Then they have a while loop, and they're saying while 1 is less than 0, and while 1 is greater than the number of games. They're going to take invalid input, and they're going to prompt it again. This is going to keep happening until they get a valid input within a specific range. Then they calculate the ratio, and they print out the output. Here's the example run. They enter a -5, invalid input. They enter 13, that was invalid input. Finally, they enter in 7, and then they print out their percentage. Infinite loops. The body of a while loop eventually must make some condition false. If not, it's called an infinite loop, which will execute until the user interrupts the program. This is a common logical error. You should always double check the logic of your program to ensure your loops will terminate normally. And then here they have an example of an infinite loop. They have a variable count. They set it to 1. They're saying while count is less than or equal to 25. They print out the count and they subtract 1 from count. The loop will execute until interrupted, or until the underflow error occurs. What's going to happen is it's going to keep going over and over and over again, because instead of incrementing their count, they're decrementing their count. So they're actually getting more negative. So they're going to 0 and then -1, -2. Now at some point it is going to stop, because the way integers work in Java is going to reach the lowest possible value, and then it's going to go to the highest possible value. And at that point, the loop will stop. Nested loops. Similar to the nested if statements, loops can be nested as well. That is, the body of a loop can contain another loop. For each iteration of the outer loop, the inner loop iterates completely. See palindrome tester. So here's another program that they created. They have two string variables. One of them is set to y. They have a left, they have a right. They create a scanner object. Then they have a while loop that is using this string, and they're invoking the equals method. So they're basically checking to see if this string contains y. Then they print out enter potential palindrome. They're going to save that input. They're going to set left to 0. They're going to set right to the length of the string -1. Then they have an inner loop, which is using the integers left and right to compare characters within the same string. And they're making sure that left is still less than right. So they're basically like incrementing left and decrementing right. So they're just looking at each character. Eventually this is going to stop. And when this inner loop does stop, if left is less than right, then it's considered not to be a palindrome. In all the other cases, it is a palindrome. Because if it is a palindrome, that means you're incrementing left and decrementing right so much that left and right are equal to each other, because you made it to the middle of the word. and then they print out test another palindrome. If you enter in Y, then you're going to stay in the loop. If you enter anything other than Y, then you're going to exit the loop. If you go back and look at the outer loop, you only stay within the outer loop is if you enter in Y. And here's a sample run. They're prompting the user to enter a palindrome. The user enters radar. They output that it is a palindrome. They ask if the user wants to do it again. He hits yes. And then he enters in another one. And they're saying this is a palindrome as well. And then test another palindrome. He says yes. He enters another word and that's not a palindrome. Test another palindrome. He says no and the program exits. So quick check. How many times will the string here be printed? You have two loops here. Count 1 is equal to 1. While count 1 is less than or equal to 10, you're going to increment count 1. So that means this outer loop is going to execute 10 times. Then inside of your inner loop, you're saying while count 2 is less than 20, print here and then increment count 2. They're setting count 2 equal to 1. But notice that this is not a less than or equals to, so that means you're going from 1 to 19. This inner loop is only going to run 19 times and not 20 times. This outer loop is going to run 10 times. So this is going to run 190 times, and here's the result. Okay, so I've created this program so that it can demonstrate the while loop. So I'm going to do kind of what they did in the book where we're calculating an average. So I'm going to calculate an average, but I'm also going to use a nested while loop to prevent the values being entered in for the grades to be outside the range of 0 through 100. So I imported my scanner class and I created my scanner object. I have a count because I'm going to count the number of grades that they enter. I have a sum because I'm going to take a running sum. So I set my sum equal to 0. And then I have the grade. The grade is going to be the actual value that they enter. Then I have this Boolean variable that I'm going to use to control my while loop. I named this done. So if done is false, meaning you're not done, you're going to keep executing the statements in the while loop. So then I output the statement, enter all your grades 0 through 100 or a -1 to quit. And then I'm going to enter in my while loop. And then inside my while loop, I'm going to go ahead and prompt the user to enter in his grades. So here's my while loop. I'm going to keep executing the statements in my while loop as long as we're not done. So the first thing I want to do in this loop is prompt the user for the grade. So I prompt the user for his grade, then I store his grade inside the variable grade. Now the next thing I want to do is make sure this grade is within a range. So if the grade is not 0 through 100 or if it's not -1, then I want to prompt the user to re-enter the grade. So I'm basically going to give him an error like invalid input, and I'm going to just keep him there until he enters in a valid grade. I'm going to use a while loop to accomplish this. So I created this inner loop that is going to validate the input. So I'm making sure that grade is not less than -1 and grade is not greater than 100 because any value that is outside of that range is invalid. Now a -1 is a valid value because a -1 is what I'm going to use to leave the loop. But if they do enter a value that's outside of the range, I'm going to tell the user that the input must be 0 through 100 or a -1. And then I'm going to prompt the user to enter the grade again. I'm going to store their grade inside of this variable. They're going to be trapped inside of this while loop until they have a valid input. The next thing I want to do is I want to set my control variable to a Boolean expression that is going to determine if I need to leave the loop. And if I don't need to leave the loop, then I need to do some calculations. So for my control variable, I'm checking to see if grade is equal to -1. If it is equal to -1, then I know that I'm done. But if I'm not done, I'm going to go ahead and add the grade to my running sum, and then I'm going to increment my count. Now I'm pretty much done inside of my loop, so the next thing I need to do is outside of my loop is display my average. So here's how I'm displaying my average. First, I'm checking to make sure that count is greater than 0. If count is greater than 0, that means they've entered in some grades, and then my sum divided by count, I'm going to get my average. So if count was ever 0, that just means that the user never entered in grades. The very first prompt, he entered a -1, and I'm just going to output, you did not enter any grades. So let's compile and run this program. So the first thing I want to do is I want to verify the case where I don't enter in any grades. So the first input, I'm going to enter a -1. And when this happens, I get the message, you did not enter any grades. Now what I want to do is enter some grades, but then also enter some grades outside of my range. As you can see, I entered some valid grades, but then I entered in a 900 and I got the message, input must be 0 through 100 or a -1 to quit. Then I entered a -2 and then I got the error message again. Then I entered 100, which is a valid grade, and I entered -1 to quit, and then my average was printed out. Alright, so that's it. So within this one program, I was able to demonstrate several things. The things that I demonstrated was using sentinel values to break out of loops. The other thing I demonstrated was using a while loop to control input validation. And another thing I demonstrated was having nested loops. I have two while loops inside of each other. So loops are very powerful. They can make your programs very interesting. I know it's going to take some time to wrap your mind around all this. Practice makes perfect. Just sit down, think about what you need to do, write some pseudocode, and practice doing this. Take one step at a time. Make really simple loops. Don't try to write all your code at one time. Do incremental compiling. That means as you're writing your code, compile your code to make sure you didn't make any mistakes. Don't wait until you've written 100 lines of code to compile, because then you might be left with a bunch of errors that you need to correct. So I created this program to demonstrate infinite loops. So right now I don't have an infinite loop. I have a loop that's going to be controlled by count. So I said count is 0. And while count is less than 25, I'm going to print out what the count is. But at the same time, I'm also incrementing count by 1. So this loop is going to execute 25 times, 0 through 24. So I'm going to go ahead and compile and run. And here's my output. You can see that I started from 0 and I went to 24. But let's just say we made the mistake that the book made, where instead of incrementing, we actually decremented. And let's see what happens. As you can see, I'm stuck in an infinite loop. Now, at some point, this number is going to get so negative, it's going to reach the lower limit of the integer, and it's going to reset itself because it's going to go to the highest possible value for an integer, and the loop is going to stop. So you need to be careful when you use loops because you could find yourself stuck in an infinite loop. So I'm going to go ahead and modify this loop. I'm going to change it to a byte so that you can see what I mean, that the number will get so negative that it's going to go back to the highest value for its data type. So I changed count from an integer to a byte, and now let's see what happens. All right, so it looked like we got stuck in an infinite loop because we're going the wrong way, right? So we started off at 0, then went -1, but a byte is actually pretty small. So once it got down to -128, it went to +127, and at that point, count was no longer less than 25, so the loop stopped. So if I would have kept waiting when count was an integer, it eventually would have stopped. If you ever find yourself in an infinite loop and you want to terminate the program, use Control-C. Control-C will stop the program.